So I'm Vincent. I'm the CTO for Red Hat in Asia Pacific, based in Singapore. And the topic that I'm going to focus today is really around the term that you've probably heard a lot about, AI agents. But I'm going to take a slightly different focus. We are going to look at the supply chain safety of AI agent, i.e. how do we actually build as developer AI agent using cloud native technology in a way that is both transparent and safe. So let me start a bit with situating the problem. We obviously see a huge amount of adoption of AI technology, and I think by then, if you follow a bit the debate, it's quite clear that what enterprises are doing with AI is they are not rebuilding systems from scratch. They have a lot of legacy technology and systems typically built into services that they have painstakingly built over the years and integrated. Think about it, they just spent the last probably 8 to 10 years or so rebuilding, microservice architecture, trying to run them on Kubernetes and container. So now AI comes, and no one really wants to rebuild the system from scratch. What people want to do is they want to take AI capability and agent and embed them, integrate them within existing application. So it's very interesting because everyone in this room, the interaction we have with GenAI is basically the ChatGPT, kind of all powerful model, can ask any question and get things done. But the way AI actually works in enterprise is absolutely different. It's kind of smaller, fine-tuned expert model that people are really testing against a very, very specific task. So that's what they are really building at scale. And the reason is they are going to progressively embed intelligence into application. There is no such a thing as out of nowhere, a full potent AI application comes, and now it's running in your bank, it's running in your healthcare, it's running in your nuclear power plant. Like, no, guys, this is dangerous. Don't do this. So, given this pattern of adoption, the biggest gap that we have today for AI is actually the AI trust gap, from my perspective. A few reasons for this, right? The first one is explainability. You see a lot of magic happening out of GenAI, but few people are actually able to explain what the outputs are and why you actually get a specific output. It's generally fine when the human is going to use the output and mitigate them. But when we are talking about AI agent and we start talking about autonomy, obviously you need to be able to explain the decision of your agent. So that's critical. The second one is data privacy. A lot of the models you see out there, if you take, I don't know, maybe the best Llama model, now the biggest that there is, Meta has probably used most of the clean internet data out there already to train this model. So you've got no additional learning from public data. The entire model capacity is now dependent on your own enterprise data, right? The specific business knowledge that you have accumulated over the past 15, 20, 30 years sometimes in your systems, in your database, in your file. This data is extremely sensitive because of economic consideration, because of regulation as well. It embeds your customer practices. It's not something that you can easily throw into some cloud provider and just get a model to pick it up and fine-tune it. And so that has to be done with a lot of care. The third aspect is ethical and bias. I think this morning I was in another presentation on sovereign AI, and what we explained was how important it is for specific countries due to their culture, their language, to actually build their model using their own data. And one of the reasons of this is because the data implicitly contains the bias that our society has. Bias is an interesting term because everybody thinks it's negative. But think about it, right? A lot of bias we put in place in our society is actually due to how our values or culture or usage actually works, right? We actually need to have this kind of bias as a society to function. So I always have this very interesting discussion now, almost philosophical, that with AI, we are not trying to remove the bias. We are actually trying to ensure that the patterns, the bias, the behavior that we see out of the AI is aligned with human value. So think about this term, right? Alignment is very important. No bias is not possible. But do we accept that the behavior of the AI is aligned with what we would do as a human? Does it follow the same principle? That's what is important. The last bit is the supply chain. We've started to have very visible supply chain attacks directly within AI technology or even the model itself. Right, so I think the last one was AWS with the MCP framework. I mean, you can get an MCP tool to literally erase your hard disk by making a simple open source contribution. Shows you how powerful open source is, but also how dangerous a project with no proper supply chain practice actually can be. So in AI, we actually have very complex supply chain that don't contain only code. They contain data, they contain benchmarking, they contain alignment practices that today you probably have no ability to understand what's behind the scene whenever you pick an AI model from Hugging Face. So think about this, 1.5 million model available today on Hugging Face. Probably 99.9% of them, you actually don't know what data they are trained on or even what benchmark the provider has actually used to make sure that this model is secure. So it's both beautiful and scary at the same time. Yeah? So what I'm here to share with you is some of the work we are doing in a few open source community to start looking at this problem. We haven't solved it, but we are doing a lot of work to see how we can start to identify solutions. The first one is basically the LF AI and data as a group called the Gen AI Commons, which I'm actually part of. And some people in this group spend probably close to 6 to 9 months coming up with a responsible Gen AI framework. Now, what I want to say is, this is not the first or only Gen AI framework. If you search on Google, you probably find about 100 of them. But this is the only open source one. So what does it mean? It means that the framework is going to keep evolving based on the feedback of the community. It's not the framework based on one group of people agenda. That is very important. Yeah? So I'm not going to tell you here that is the best framework. You can, in fact, there's very good paper, even from the closed model provider. Anthropic has very good paper on AI safety. Do read them. But this is an attempt to start having a discussion with the community on responsible Gen AI practices. So that's very important. These dimensions that you see here, they can sort of guide our ability to contribute to open source projects that are going to advance AI practices within the trust domain. So that's what we use it. We have started to use them as Red Hat to prioritize what kind of project we actually want to contribute and what kind of technology we want to guide. Now, if I take this responsible Gen AI framework and I map it to core enterprise challenges, there are 3 pillars that are extremely interesting and important. The first one is the pillar of robustness, reliability, and safety, which maps directly to the concept of transparency. The way you should think about this is the black box problem. If I pick up a model, how much do I know about what ingredients went into the model? To use a bit of a cooking analogy, right? If you go and buy some food out there, in some location, you'll have a very detailed breakdown of the ingredients that go in making the food. Some countries also have a health label. They'll tell you it's A, meaning not too many calories. This is like pretty bad for you, don't eat that every day. So the more information you have, the better, because you can take a decision. Doesn't mean that you shouldn't eat, rich food from time to time. But it means at least every time you eat rich food, you know it's rich. So same with AI. If you have a completeness of disclosure, you can actually decide on your own whether you are comfortable with using the model. That's very important. The second pillar is transparency and explainability, map actually to the supply chain. So for those of you who are maybe familiar with data science, in data science there is a process which is called the experimentation. That's when I start to take my data and I build and train my model and then start to use the model and align the model with the output that I want to get, right? And part of this process, obviously, is to have a very well-defined set of benchmark and tests that I want to run to define like a pass grade, right, for the model. Now imagine that we could capture everything that's happening in that experimentation phase. Which data sets are used, what's the provenance, what is the code used for testing. But we can start to audit those practices and provide assurance to the people receiving the finished product that you can have complete disclosure of the practices and components. Yeah? So that's what the supply chain is about. That's what we want to build. And then last but not least, even though you trust the supply chain, you will still need to be able to evaluate your model and your technology for your own use case. So that brings me to the last principle and pillar, which is accountability. Accountability, we look at this pillar from the angle of evaluation and risk. When I run testing against my AI, I want to do it at the system level, not the model level, and I want to evaluate the performance of the system versus the risk for my business. That's what it means. Let me use a very simple example, banking. Let's say I use a GenAI model to recommend the purchase of a stock. I can test the model on its recommendation. Now let's take a few use cases. Let's say in my first use case, I use the recommendation engine to a veteran banker who's been doing 25 years of investment. Is it risky? Not really, because he's going to read the output. If it helps him, he will use it. If it doesn't help, he will just override. The system itself, from a risk angle, is not a system that is very complex to build and to the point that you get an acceptable performance and risk. Now imagine I use the same recommendation engine, but now it's actually recommending your grandmother to buy the stock. Now are you okay with that? Not so much. Now imagine now the same system doesn't even take a recommendation. It's now an automated trading engine that is investing $1 million of the bank money in trading, just hoping to make a profit. I'm using the same recommendation engine, 3 different use cases. The risk profile is totally different. Yeah? So we really need to build new evaluation framework to address this kind of requirement. So I'll try to go now through some of the pillars, a little bit more into detail to give you an idea of what's happening now in terms of open source engagement and technology to address some of these problems. So transparency first. We have an initiative, again, under LFAI and data called the Model Openness Framework. The Model Openness Framework defines 15 different types of elements that are needed to build an AI model. It's like the ingredients of your recipe. The Model Openness Framework mandates that you should disclose all the elements, so there should be complete disclosure, but it doesn't mandate that every ingredient should be open. Why? Because it's not practical. You are going to have data sets that are not open source. So you'll see a lot of this debate in open source today. I've got friends who are telling me, you have the open source model and a non-open source model. And it's like a big competition here. It's a wrong debate. Open source, to me, doesn't apply to the model. Open source can only apply at the lower level to the component. I can open source a data set. I can open source training code. Open sourcing a model doesn't mean anything, from my perspective. So what the model openness framework does is, instead of telling you a model is all black or all white, it tells you how wide the model is, how transparent. So you get a transparency rating. And this transparency rating is based on how many components are disclosed and available to you under open source license. If you get 0.9 transparency, believe me, this is a very, very open model. You are at the top of the industry already. You don't need it to be fully open. That's kind of the point. Within the MOF, we have 3 categories. Open model is what you are going to use for most enterprise use case. And they mandate that you have at least model architecture, model card, full disclosure of all the components. If you are going to build solution a bit deeper, then probably you want to go to the class 2, which is open tooling. Open tooling, you need to have the training code, the inference code, and the evaluation code, at least to qualify. That means you really understand and you can, to some extent, reproduce the process of making the model. Open science, which is everything open, is almost a theoretical use case. I think people doing open science will be only academics. Yeah? Oh, I've got a nice open model and you can reproduce the full model build yourself. Great for academics. For practitioner, we actually don't need it. So now, for an application developer, this gets interesting. Because the way that we work with AI, typically, when you think about the inner loop of the developer, the way we do it in real life is we will try an LLM, we will prototype an ID, and then the LLM result will be bad. Then we'll try another LLM, we'll try to change the code, we'll try to change the prompt, we'll try to add some RAG. It's a lot of kind of tweaking, like the system, right? Like it's a constant loop. So this process, by definition, is going to make the whole decision of what component you use very important. And also for the downstream people who are your IT security folks, the people actually looking after the enterprise, they are going to be extremely scared of what ingredients you are going to use in your recipe, to be honest. So the question for me is, as a developer, how, or rather as a technologist, how can I guide the developer in terms of what model to select, how to build application using best practices, right? How to cook, and then how to deploy in a secure, trusted manner. So from Red Hat, we introduced a project called RamaLama. Who in the room has heard about Llama before? Are you using it? I should see quite a few hands there. Yeah, so Llama is great because you can run your model on your laptop, on your desktop, and then experiment with kind of small language model, right? Llama, though, has a big disadvantage. Honestly, the provenance of model is a little bit rubbish. I'm sorry for the word. Sometimes they even use a model naming which is not in line with the model standard from the provider. So you'll have like really, really bad surprises. Also, the toolchain is absolutely not secure. You can literally, once the model runs on your laptop, anything can happen. Yeah, if there is some kind of virus or whatever out there, like good luck. Yeah? So what we did with RamaLama is we actually went down one level of Llama to Llama CPP, which is the framework. And we basically started to use container and OCI technology to provide first automation, and then to support the entire deployment and iteration process for the developer. So how we do this, we basically provide trusted container image of the entire tool set that you need for AI, right? So it's Llama, the libraries, and everything. We also help you to automatically manage the deployment on your trusted laptop or desktop. We detect if you have access to GPU. For example, if you have like a MacBook or a Mac Mini, it will automatically detect them. It will use projects like Vulkan to automatically help you run accelerated image on your laptop. So it simplifies the whole infrastructure management. But most importantly, when you run the model, it will basically serve the model on the container image as a read-only component. And so that means now you are running in a totally trusted, secure environment, although you are on your local environment. And this environment, right, the way you are approaching it using OCI container, it gives you a highly reproducible capability to deploy on an enterprise construct like a Kubernetes cluster. Yeah? So that's what is very interesting with this project. There's a lot of benefits, obviously. You'll see later in the demo, if I have time. It's extremely simple to deploy. You just need to do a RamaLama serve RamaLama serve Mistral, and it will literally run an inference endpoint on your laptop. CLI 30 seconds, it will download everything you need, and pretty much gives you a model serving. Data privacy and security. I think we hear a lot about the revival of local development process for AI for two reasons. A lot of inference framework, they've been optimized now. A lot of model optimization now are available. Quantization is one of them, but it makes the model very tiny. And the third reason is like, believe me, because I spent a lot of cloud credit last year, and my boss wasn't so happy with me. So I had to start doing more development local. But essentially, you can do 90% of your local development, and then only move to the cloud or your infrastructure when your code is relatively stable. And then that's when you start paying the bill. So it's an extremely good, kind of win-win, because you have secure data and also reduce cost. Let's move now to the supply chain angle. So on supply chain, we are working with slightly different open source organizations. One of them is the CNCF, because we want the supply chain to be cloud native. And the other one is OpenSSF, because OpenSSF has done a lot in terms of standardizing some of the security practices, especially around use of cryptography to provide assurance for components and supply chain. So we don't want to reinvent the wheel. We want to use open source projects that are already out there and just extend them to manage AI capability. So what you see here is what an AI supply chain will look like with this new tooling. On the left, when we do packaging, we've actually come up with a new standard called Model Pack. Model Pack is now an incubating project within the CNCF. And Model Pack essentially is using OCI standard to package the entire set of components that I showed you earlier on the MOF. So think, now I've got the MOF, great, but how do I operationalize the model openness framework? I operationalize it with Model Pack. Model Pack will basically take all these components, package them into one single container image. During the build process, we can now perform a signing. So for this, we are actually using the Sigstore project, and we have developed a new capability under Sigstore, which is called the Model Transparency project. So Model Transparency gives a little utility that allows you to do model signing with an OIDC provider of your choice, or potentially with public-private key capability, right? Either way. So when we do this, we take all the components, we actually generate the AI bill of material in an SPDX-compatible format, and then you have a container image with all the recipe, the components, and the cryptographic signing. So when you are shipping the result of your hard labor as a developer to the to the ops team, they basically can use their existing cloud-native infrastructure, their container registry, their security practices. They can do the same container scanning as well to review whether the bill of material kind of compliance and policy are actually agreeable with their standard. So it's a very powerful construct because it is based on practices that we have already established over the past years or so in many of the organizations around the globe. Yeah? And of course, it's cloud native. So it all runs on Kubernetes, right? You can use GitOps principle. All the supply chain essentially is infrastructure as code driven. For you as a developer as well, I don't know how many of you have had a chance to download Podman. So Podman is our cloud native tooling, for you to have access to kind of running container and developing on container on your laptop. I use Podman extensively. We have a Kubernetes, enterprise Kubernetes project. I'm going to be honest with you. I use Podman a lot more than OpenShift from Red Hat, right? It's recorded, unfortunately, but it is the truth. Because obviously, a lot of the work I do, it has to be kind of working before I actually push it to a cluster. So Podman is very good for this, but we've started to extend Podman now to cover as well the AI lifecycle. So it doesn't appear on this slide, because what I want you to get here is, in Podman, you can basically do this kind of AI development process, and then you can just create a kind cluster within your machine, and Podman will basically automatically generate the YAML you need to deploy your entire AI stack on a Kubernetes cluster locally as well. So you are actually testing on Kubernetes already. Which is, it means you'll be in a very similar framework as ultimately your enterprise team will be once they actually deploy this, the manifest in production. That's what I want to say. The closer you can get to kind of production-like, the better it is. Yeah? And I'll finish with the last pillar, which is evaluation. So what's the problem of evaluation with agent? Well, if you look at the little picture I have on the right, the problem with agent is the more autonomy they have, the more it means they can talk to other agents, they can call tools, but you have no idea what agent will be called, how many times the tool will be called. You don't even know what sequence it will be done. So when you are trying to explain and test the process itself, then the question is, if you can't actually condition the testing flow, how do you even test and validate that system? A lot of the way we do code, I've always been a big fan of test-driven development. I don't do a line of code typically until I have a few hundred test cases, personally. I hate writing code without a test case. But in classic IT and software, we can write the test case in a very deterministic manner. We know exactly what part of the code will actually be executed when we have written the test case and the code. But with GenAI, we have no clue. So to me, it was very disturbing, because I was trying to build software based on agent, and I'm like, I don't know how to write a test case. So what am I supposed to do? And it's very important as well, because there is also a notion of reliability as well. The whole workload could actually execute, meaning I could have agent A call agent B call agent C, who calls tool A and B, and it will send me back an answer, which means in IT terms, yeah, successful. But actually the answer is terrible. So what do you do with this, right? Because from a system safety perspective, a bad outcome, a bad answer, is actually a fault, right? So normally I have a fault tolerance mechanism, like the middleware will republish, will retry. But in this case, it won't, because I actually received an answer. So that's the second problem we have. We cannot rely on traditional fault tolerance mechanism with agentic, because the notion of fault is actually different. And that is scary, because 50% of enterprise are already saying confidently that I'm going to deploy agent by 2026. And I'm like, how? I work on this all the time, and I don't have a clue how to make your system trusted. How do you even know by 2026 we can actually make this happen? So the way I looked at it is, we need to start thinking about how do we evaluate the ability and the risk of a system. And what I discovered by looking at a lot of strategies and research paper and everything is probably the way to go is to have a very holistic evaluation cycle. By holistic, I mean from a few different angles. First, from a lifecycle perspective. When you're doing evaluation, you can run evaluation during the testing process, but you need to have constant evaluation as well after the model and the agent is deployed. That's one aspect. The other aspect of holistic is don't rely on benchmark. You have hundreds of benchmarks out there. They are all equally terrible in a way. You should still run them because they are a starting point. But just be aware that they are terrible because they are biased benchmark. They have not been built based on your use case, and the model provider have already retrofitted the performance of the model to succeed on the benchmark. So it will give you an illusion of readiness, which is the worst, right? It's better to be ready but think you are not ready. But when you think you are ready and you are not, generally that's when bad things happen. So that's the problem I have with benchmark. I have a lot of customers, they tell me, I'm confident because I tested my system with 100 benchmark and we all cleared them. In production, the system is not going to run against the benchmark. You will have an actual user trying to game the system or trying to get an advantage from how bad your system has been built. So it will fail. Yeah? And then the last aspect of holistic is you don't want to trust only the technology. So you always need to have a human element in the process. The human element could be in the test case, it could be in the calibration of the model performance, it could be in the review as well of the model performance on an ongoing basis. Probably all of the above, actually. Yeah? So we started to look how we could start to embed some of this evaluation natively into the way agentic systems are running. Right now, I'm using a framework called DeepEval, and DeepEval is not perfect, but what I found it to be very good for is because DeepEval gives me a way to scale evaluation. It can provide me a construct of LLM as judge to do my evaluation automatically, so it gives me scale. And then the other is DeepEval is relatively adaptive because it gives you a way to build your own human-driven evaluation. So you basically build your own prompt, that are human-specific to your use case, and you embed it into a methodology called geval, which basically you will use your prompt to evaluate the outcome of a question with a model. So you can use this to do very, very detailed evaluation and assessment. Of course, you don't want to run this manually without human review. You still need to have human review constantly to improve those evaluation as you go along. All right, so I don't know how much time I have for demo, actually. Probably very little. Do we have a time? Okay, never mind. I'm going to try to cover a very simple demo for you, which is this, right? So showing very quickly how I can do local development and testing with RamaLama. And then how we do model packaging and signing with Sigstore, and then deploy to Kubernetes with Podman and Kind. That's kind of my entire demo. I actually have a repo at the back, so when I publish the slide after the session, you can go back and go to the repo, then you can try it yourself. I'll try to show you what I can within the limited time. All right, so I'm not very trustful of the internet connection, so this is a movie, but I'll kind of go through. So as you can see now, I'm on the command line, and I'm going to use RamaLama essentially to download and serve a model. So right now, when I do RamaLama list, it tells me the models I've already downloaded from typical repository. Could be Hugging Face, could be Llama. It could be an OCI registry as well within your enterprise. In the case you cannot go outside, which obviously is most enterprise. They will not let you go to Hugging Face and download. Then how to use it? Very simple. RamaLama serve Llama 3.23b, that's it. Yeah, it's literally now serving the model on my local machine. If my model was not already downloaded, it would have literally gone to the registry and downloaded the latest version. That also gives me a client, very simple web client, where I can interact with the model with a traditional chat capability. So now I'm asking this model, which is Llama, about NVIDIA, and I'm asking the model about some recent litigation faced by NVIDIA. I get an answer, not bad. You can see the speed. I'm running on a MacBook, by the way. So it's pretty fast for a MacBook model. But the big issue with the answer, if you see it quickly, is everything is from 2020 and 2019. Of course, the model was trained a couple of years back. It doesn't actually have an updated data set. So as a developer, I want to do something very quick, which is, well, embed some additional data using a RAG construct. I can do this with RamaLama. So I have a few PDF documents that are actually NVIDIA prospectus. So they are freely available in US, right? Every quarter you need to disclose a certain number of information to the regulator. So I downloaded those 2 prospectus from NVIDIA, and they actually gave me some information about NVIDIA litigation in particular. Now RamaLama gives me a tool which essentially is going to take this prospectus and is using a vision model, an OCR model at the back with a project called Docling, which will automatically take this PDF, understand the context of the information within the PDF document, and automatically create vectors from the PDF document that I can capture in my own vector database. So how I'm doing this is just on the command line running this RAG. I'm not running it because it takes a couple of minutes. But essentially, once I run this RamaLama RAG command, it will actually create a new image that will be an image of the RAG database plus the data. So this image now, I call it RAG data. So think about it. Now my vector database and my vector data is self-contained within a container as well. So when I'm actually going to deploy, I'll have the model libraries, the language model, and now the RAG database and the data, all containerized. They are all layers of a container. Super powerful construct. Yeah? So now I'm running again the serving, but this time I'm serving the model with the vector database. And so I pass, obviously, my new RAG image, which contains the data. And again, I'm using the Llama 3.2 model. At this point, by the way, you could decide to choose a totally different model. So if you want to go a Mistral model, fine. Just go along. So I'm serving again. Let's try to accelerate. And so within the CLI as well, I can directly ask questions. So I can do a RamaLama serve or RamaLama run. When I do RamaLama run, I'm basically asking the question directly, which you can see in the CLI here. And I ask the same question as before in the web interface. But this time, as you can see, I've got 2023 data. So it's basically now picking the data from the RAG database. Yeah, with the same serving endpoint. That was pretty easy, was it? To build a RAG. Very hard to build a RAG faster than this as a system. Yeah, you can find code of the internet and so on, but it won't be as convenient and as powerful. So now I've done my base system. I can basically use this command called RamaLama convert. And what this command will do is will take all these components, like the model, the RAG, and it will produce one single container image, and it will actually push this container image in my QA registry. So from there, I can actually share the work I've done with all my developer friends across the enterprise. They just need to download the whole container now. So that will take a bit of time as well. So I'll just pass. So I'm done now. And so once I've produced this image, again, I'm using my Podman command line and just kind of looking at what was produced and trying to highlight it as well. So you see here now I have a new image, which is the RAG model. Yeah? Loaded 31 seconds ago. So from that, this is the construct I'm going to distribute pretty much throughout my entire enterprise. All right, so I think that's it for this demo. So I want to try to do quickly the model signing as well before we conclude, to show you as well how simple it is. So I'm using the command line tool. Bear in mind, we also have a Kubernetes version of this that does it automatically. But it's better to show you the command line so you understand how it works. So what I'm doing here is I'm actually taking now a much more complex model from Hugging Face, and I'm getting the entire set of components from the Hugging Face repository. So I'm just doing a git clone on my local machine to do this. And I think it's a very simple model, which is Finbert. So the cloning has happened. And so now I've got a Git repo very much with the model components, at least with the manifest on my local machine. I remove pretty much the kind of Git management because I'm not going to obviously change the code or version it. And I don't really need to package this, right? That's actually a relatively small size here because I've only downloaded the manifest components. I don't, I've got basically linked to all the components at the back. I don't need to download everything from that repo. From the model signing, I've done the pip install model signing before, so it's there. Sorry, I haven't done it before. That's why it's not working. So you just basically install with a pip install. So that will basically bring the model transparency component and project from Sigstore that allows me to do model signing, including all the dependencies like the cryptographic libraries and so on. So now what I do is only model signing sign Finbert. And so now it's going to basically start the signing process. And by default, it will use an OIDC provider. It provides me with an HTTP link, which now I will put in my browser. So now I go in the browser, it will allow me to select an OIDC provider of my choice to authenticate myself. And I choose GitHub because I'm already logged in GitHub. So you didn't see me having to log in. And so now I've used my GitHub auth to actually assign the image, which means now people can verify my identity and they can basically verify the signature of my model when I promote the model deployment across the enterprise. Yeah? So that's what you see here. I have a new file which is called the models.sig, which is the model signature. And I can now verify the integrity of the model during deployment against the signature and against my identity. Obviously, in enterprise, most people will not use a GitHub OIDC. They may use more of a public-private key infrastructure. And the project also supports it, right? I just wanted you to give an idea of the process. So now I'm just doing a very simple test of verification, model signing verify, and I'm basically passing my own auth, right, which is my Red Hat email address and my identity provider address as well. And if the signature and my identity match, normally the model signing component will return to me a success, right? Verification succeeded. If not, well, I'm kind of hastening the test here. Like in this case, I've changed my identity. The process basically complained that Vincent Caldeira at Gmail is not trusted, yeah, because it's not part of my org. All right? So that's what I wanted to cover, more from the kind of supply chain angle. And so I think we've covered the main elements that I wanted to demonstrate today. I just want to leave you, if you are interested in the process, I've actually published 3 blogs with LFAI and data. They basically cover the 3 parts of the supply chain of AI, end-to-end, taking into account how you develop locally, how you comply with the model openness framework with tooling, and they also cover the licensing aspect. We have a new licensing construct called the Open MDW license. MDW stands for Model Data Weight. And that's a new license we are promoting really in line with the model openness framework to give visibility on the transparency of model. All right, so I hope it was helpful. Thanks for your attention. And I'll be around the event if you have questions. Thank you.